When dealing with Mars, we have one more thing to consider, specifically water. So many spacecraft, as we have studied Mars, have shown evidence for liquid water. So in this image, what we're looking at are what appear to be dried up riverbeds. Okay, so these are known as dendrites on the Earth. What happens is we get rainfall in high regions like mountains. Okay, then as gravity pulls this stuff together, the water collects together first into small streams, and then those merge into large streams that feed into rivers, and then rivers eventually feed out into oceans and lakes and seas and stuff. Okay, well, we see this sort of feature all the time on the Earth, caused by liquid water, and here is something that very much looks like that, but again, it appears to be dried up. Okay, so upon sending some of our first missions in the 70s to Mars, we have the two Viking landers, and where they landed showed absolutely no evidence of water. No evidence of water at all. It did show a type of chemical referred to as peroxides, which is kind of interesting. It has quite a bit of oxygen in it. But again, the Viking orbiter again showed evidence of flowing liquid water. So in this image, this kind of appears like a river. So we would have the water flowing from the bottom of the picture to the top, and as it hit the crater, it would actually flow around, creating these sort of islands. Again, this is something that we often see on the Earth, created by the flow of water, in rivers and these sorts of things. So again, this would suggest that at some point in the past, there was actually flowing liquid water. So in the 90s, we sent the Mars Pathfinder mission, which had the Mars Pathfinder rover. So this kind of think like remote control car that we were able to drive around. Well, in the region where it landed, it found a lot of volcanic rock. It also found impact breccia, but it also found sedimentary rock. And the type of sedimentary rock that it found is consistent with forming at the bottom of large bodies of water over extended periods of time. So again, suggesting liquid water. So in the 2000s, we had a follow-up mission, we've sent the Mars Exploration rovers. That's imaged here. So down here, we've got the Mars Pathfinder rover, then we have the Mars Exploration rovers. We actually sent two, Spirit and Opportunity. Spirit landed in an area that showed no evidence of water. So based off of orbiting spacecraft, we didn't see anything that suggested rivers or lakes or anything. But it did suggest volcanic activity. And the Spirit actually found volcanic rock, which makes sense. But a little bit more interesting, it also found these outcrops of sulfur salts. So sulfur salts are left behind when regions of water that are high in sulfur evaporate. So this area may have been something like Yellowstone. If you've ever been to Yellowstone National Park, particularly around the hot pots, those things smell strongly of sulfur. So maybe this area had a high water content, had things like the hot springs and the mud pots and the hot pots and these sorts of things. But over time, the water eventually evaporated, leaving behind the sulfur salts. Now, if this was the case, the area would have dried up literally billions of years ago, but the idea is there and very interesting. Now, the region where Opportunity landed showed evidence of sedimentary rock and therefore extended periods of liquid water. It found outcrops of sedimentary rock and also regions of rich in sulfur. So we're fairly convinced that there was liquid water on Mars, so what happened to it? Well, it all goes back to Mars losing its atmosphere and cooling off. There are some regions that we see here and there that have large amounts of permafrost, where the water has actually sunken into the ground and then frozen. We also have the polar ice caps, which are also rich in water. So this is what we believe happened, that as Mars cooled, the water all got locked away as ice in the ice caps or as permafrost. Now, occasionally we do see possibility of running water. So in this case, we're looking at the edge of a crater where the permafrost would be exposed to sunlight. The water would then get melted and create these little rivers, for lack of a better word. However, notice that the water is not actually pooling. Because of the thinness of the atmosphere, the water is going to be evaporating very, very quickly. All right, here is our fifth clicker question. What happened to the water on Mars? A, it was harvested by other worlds that had a lack of water. B, it boiled off due to the high temperatures. C, as Mars cooled, it became locked away in the polar ice caps and as permafrost. Or D, it was broken up due to solar radiation into other chemical compounds. Go ahead and think about it, and we'll discuss it in just a little bit. All right, so based on everything we've talked about, the answer is C. As Mars cooled, the ice got locked away in the polar ice caps and as permafrost. But what this means is that Mars should have significant amounts of water ice, which is exciting because this means if we go and try to make a permanent presence on Mars, actually create Mars colonies, this is one resource we won't have to bring lots and lots of. We may be able to figure out ways of harvesting it right off of Mars. So on to moons. Mercury has no moons, Venus has no moons, the Earth has the moon, which we've talked about already, and Mars actually has 2 moons. These moons are actually very, very small compared to our own moon. They're closer in size to asteroids. So these moons are Phobos and Deimos. Phobos is the larger of the two, and it's actually closer into Mars. Deimos is smaller and farther away. Now, because of how close Phobos is to Mars, remember with Kepler's third law, the closer in the planet is, the faster it orbits. The same thing applies to moons. With how close in Phobos is, it is cruising really, really fast around Mars. It's actually going so fast that it rises in the west and then sets in the east in 5.5 hours. In other words, you can easily notice that it is moving. Deimos, being farther out, therefore means that it's going to be traveling slower. What this means is you actually do see it rise in the east and set in the west, like normal, because of the rotation of Mars. However, it is going fast enough that it just hangs in the sky. So it rises in the east and then takes 3 days to finally set out in the west. So it just hangs up in the sky for a long time. Now, Deimos is actually slowly slipping away. If you remember, we talked about how the tidal force between the moon and the Earth is causing the Earth to slow down and the moon to pull away. Exact same thing is happening with Deimos. However, Phobos is so close in, the opposite is happening. Phobos is actually getting drawn in closer and closer to Mars, which means in about 40 million years, we can expect it to actually crash into Mars. And that is going to look amazing in 40 million years. Something tells me I'm not going to actually survive that long. The last question we've got is, so where did Phobos and Deimos actually come from? Well, one possibility is that they're actually captured asteroids. If you remember back previously when we were talking about the solar system, we mentioned that the asteroid belt is located right between Mars and Jupiter, so we've got a whole bunch of asteroids right there. So one possibility is that they're actually just captured asteroids. Another possibility is that they actually formed through condensation and accretion around Mars. That Mars actually created its own proto-moon disk, and with how small these are, that seems like it might actually have happened. However, this is an ongoing question, and personally, I prefer the idea of them being captured asteroids, but right now we just don't know which is actually correct.